So this problem, our aim is to calculate the equilibrium constant for this reaction. We've got carbon-oxygen fluoride in equilibrium and decomposing to carbon tetrafluoride and carbon dioxide. The question gives us some initial and some equilibrium number of moles. So it says that the number of moles initially of carbon-oxygen fluoride is 1 mole. And at equilibrium, that drops down to 0.04 moles. Now the volume that the reaction vessel is in is 2 litres, and the temperature that it occurs at is 460 degrees Kelvin. And our aim is to calculate the equilibrium constant. Let's balance this equation so then we can write a general equilibrium expression, work out the concentration of these at equilibrium, and substitute it all in. So firstly, 2 carbons. So let's put a 2 in front here. 2 carbons, 2 carbons. 2 oxygens on the left, 2 on the right, we've got a balance. And 2 times 2 is 4 fluorines on the left, 4 fluorines on the right. We've got a balance. So 2 moles of carbon-oxygen fluoride going to decompose and form 1 mole of carbon tetrafluoride gas and 1 mole of carbon dioxide gas. Okay. Initially here, the question states that we've got 1 mole of this. And at the beginning we'd have 0 moles of these. Let's write that in, keep it nice and clear in our head. At equilibrium, it tells us that the concentration, the number of moles of carbon-oxygen fluoride has dropped down to 0.04 moles. That means, minus thing away, 1 minus 0.04 is 0.96. So 0.96 moles of carbon-oxygen fluoride have moved over to the product side. 0.96 now would have formed half of that because of a 2-to-1 ratio of carbon-oxygen fluoride to carbon tetrafluoride. So half of 0.96 is 0.48. So we're going to have 0.48 moles of carbon tetrafluoride produced. And because it's a 1-to-1 ratio here between carbon tetrafluoride and carbon dioxide, must be the same number of moles produced. So 0.48 moles. Okay. We can easily calculate the concentration of these now. So let's change them to concentrations. 0.04 moles divided by 2 litres is 0.02 moles per litre. 0.48 divided by 2 litres equals 0.24 moles per litre. And because it's a 1-to-1, stoichiometry equals 0.24 moles per litre. So now we have our concentrations. Let's do a general expression for this equilibrium. Capital K, equilibrium. Now it's going to equal the concentration of our products over the reactants. Our products are carbon tetrafluoride. The stoichiometry is 1 to the power of 1. Multiplied by carbon dioxide, stoichiometry is 1, so the power of 1. Carbon dioxide concentration. Now, the reactants down the bottom, carbon-oxygen fluoride. Now, stoichiometry is 2, so it's going to be squared. Okay, there's our general equilibrium expression for this reaction. Let's start substituting in these concentrations. Okay, carbon tetrafluoride, let's look on here. We've got 0.24, so 0.24 mole per litre, multiplied by the carbon dioxide, multiplied by itself, 0.24 moles per litre. Divided all through by the concentration of carbon-oxygen fluoride squared, 0.02 moles per litre squared. Let me just grab my calculator. Should have done it earlier. So, putting that in my calculator, well, let's put it in there. Okay, calculating that out, we get a value of 144. So, the equilibrium number for carbon oxygen fluoride decomposing to carbon tetrafluoride and carbon dioxide is 144.